Okay, we're going to take a look at what happens to the function f of x equals x squared, and as it undergoes some transformations. So the first thing that kind of has to do with this process, this investigation, is to actually graph f of x equals x squared using a graphing utility. So I'm going to be using an iPad, but you can use a graphing calculator, all sorts of things. So I'm using graph calculator app here that allows you to put in the different functions. So we'll put in y equals x squared, save, and then you end up with this graph here that is a parabola. So I'm going to sketch the parabola here on the graph provided. So that is f of x. In our case, it's equal to x squared, but f of x. Okay, the second thing that we're asked to do is what happens when we look at negative f of x. So I'm going to bring the graphing utility back and take a look at y equals negative x squared. So I'm going to keep the first function in there and take a look at what happens with negative x squared. So as you can see, it kind of points downwards. Basically, it reflects over the x-axis. So I'm going to make a note here of negative f of x, and that's going to be equal to negative x squared. This is a reflection. So what can I conclude about f of x transforming to negative f of x? It's a reflection over the x-axis. Nice. Let's see about the next one here. F of x plus 4. In other words, x squared plus 4. So in order to get a look at this, I am going to, and do a good comparison, I'm going to take that one negative x squared, I'm going to clear that out so that I can look at just x squared plus 4. And now, in the original function, x squared gets shifted upwards. So it's a vertical shift. So you've got your original function, f of x, and the vertical shift of 4. So what can I conclude about this transformation? This is a vertical shift in other words, up 4. Okay, the next one here is now we're kind of asked to look at a whole bunch of things. So I'm going to combine a couple of these on a single graph so we can compare the two. So what about f of x minus 4? So that's going to be x squared minus 4. So we've got the first one was x squared, then there was a vertical shift up, x squared plus 4, and then you have a vertical shift down, x squared minus 4. So I'm going to put that in. We've got f of x, and then you've got this f of x minus 4. This is vertical shift down. How about these two, f of x plus 4 and f of x minus 4, where the plus 4 and the minus 4 are in the parentheses? So we go to, I'm going to clear first one and the second one, or sorry, the second and the third, and we'll look at x plus 4 in parentheses, x plus 4, and then we square that, and then the other one is x plus 4, I'm sorry, x minus 4 in parentheses, and we square that. Turn the second one off. So x plus 4 in parentheses squared, x plus 4 actually gives us a shift to the left. So x plus 4 is a left shift. Can you see that there? Yeah. So you got f of x. Then you've got f of x plus 4 is left 4. F of x minus 4, you might be able to predict now, it's going to end up being the opposite. So if I look at f of x and f of x minus 4, it moves to the right. F of x minus 4, that's to the right 4. Two more sets. We're going to look at these together. We're going to look at what happens with 2 times f of x and a half times f of x. What happens to those two? So 2 times f of x is the same thing as saying 2 times x squared. And then a half of f of x is the same thing as 1/2, or 0.5, times x squared. So f of x to 2 times f of x, it gets a vertical stretch. So the red function, or the original x squared function, gets stretched vertically. So it looks skinnier, basically. So x squared, or f of x, becomes kind of two times f of x. It becomes a vertical stretch. Oops, put that on there. Vertical stretch. 1/2 f of x, that becomes a vertical compression. So it kind of gets smushed down back towards the x-axis. So we can kind of look at 1/2 f of x that's a vertical compression. The last ones I want to compare are f of 2x and f of 1/2 x. F of 2x, this time the 2x is in the parentheses, so I do 2x, then close parentheses squared, and the other one is 1/2 x, I'm using 0.5, but it doesn't really matter, you can use 1/2, in parentheses squared. So looking at the first one, what happens? Well, 2x in parentheses, this does a vertical compression. Now, vertical compression and a vertical stretch might be kind of hard to see, but a vertical compression, in this case, it's even more exaggerated. It's stretched up even higher. So this is a vertical compression. So f of 2x, here's f of x, our parabola, Just get that in there, f of 2x, and then you've got f of 2x, which is a vertical compression. I'm sorry, a horizontal compression. Horizontal compression, and f of a half x is a horizontal stretch. So I'll make a note of that here. We've got f of a half x is a horizontal stretch. And looking back to our standard in the beginning, what we've basically done is we've looked at f of x as if f of x is x squared, and we've compared what happens when you add a value to it. What happens when you multiply a value? What happens when you multiply a value inside parentheses? And adding and subtracting values inside parentheses. These are the parts of this standard of the effect of on a graph with these different parameters, adding and multiplying different values.